Good morning children. Welcome to today's physics class. Today's class will move on to the next chapter, that is chapter 13, motion and time. So already you have learnt about this topic in your previous class also. By now you all have some idea about the term motion and also about the different types of motion. So let us recollect first what we have learnt in our previous classes, and we will move on to learn the new concepts about motion and also about the time, children. So motion, what does the term motion means, children? Yeah. So what is the, you can see the images shown here, which all are indicating that motion and time are, without the calculating time, it is not possible to know about the motion of an object. So let us see first of all what does the term motion means. Yeah, motion. Motion is the change in position of an object with time. Yes, no children. Any object, if it is changing its position with respect to time, then we say that the object is said to be in motion. Again I repeat, when will you say an object is under motion? If it is changing its position with time, with respect to time, then we'll say the body is in motion. What is the opposite thing for the opposite term for the motion? Rest. So if it is not changing position, we say it is at rest. So now when we say the body is in motion, there are different types of motion. Even in the picture you can see, there is the first picture you can see a car is moving in a straight line, and you can see a pendulum there. When you all know that pendulum, when you oscillate it, how it will be undergoing the motion. And also you can see a particle which is moving in a circular path. So depending upon the path they are covering, there are different types of motion. So first here, the motion along a straight line, that is called as a rectilinear motion. In this picture you can see a motion of a car on a straight road. Then a periodic motion. Periodic is when it repeats itself with the regular intervals of time, like simple pendulum. Last year also you might have you might have learnt about that. So when the pendulum oscillates, when you are oscillating in a swing also, so how the to and fro will repeat with the regular intervals of time, such type of motion is called as periodic motion. And when an object is moving in a circular path, it is called as circular motion. What are the different further different types of motion we have learned, children? So only three are shown here. Even you can recollect, you have learnt about the vibratory motion, you have learnt about the curvilinear motion and all. So that you can recollect what you have learnt in the previous class, and just to be ready for learning the new things. So by now, motion, what is motion, you all will be, further we will move on, children. Now you see here, 4 children are riding bicycle, and 4 of them are, you can count the number, 4 of them are changing their position. So each one of them are under motion? Yes. So now how will we decide among the 3 who is moving fast or who is moving slow? This fast and slow are the terms which we in our everyday life will use. Yes, faster, that it is moving faster, slower. So what decides that which is moving faster? So among the 4, you think and keep it ready in your mind, which is moving faster. How will you decide that? Now we see. Here also you can see a person is under motion because he is walking. Another person, he is riding bicycle. You can see another person, he is driving a car, or he is inside the car, and there is another person inside the train, and he is also, the train is under motion. So among these all the 4, how can we come to a conclusion which is moving faster or which is moving slower? How will you determine that, children? Yeah, very good. So now that's how we are coming to another term, new term, that is the speed. So speed will decide whether which is moving faster or which is moving slower. Yes, no, children. So what are the terms? Speed means speed of an object can be measured if we know the distance covered by the object and the time taken. Even in the first case, the 4 children were riding the bicycle. Who is covering the distance faster with respect to time? He is moving faster. Who is covering the distance, same distance, by taking more time, we'll call it as slower. Even in the second picture, traveling by walking, by traveling in a bus, car and bicycle. So when we are able to cover more distance in a given time, then we say that the object is moving or the person is moving with with high speed, with he is faster. In common words we'll say he is moving faster. So speed is the distance covered in the given time. So for example, if a car covers a distance, just you can note down this in your rough book, children. So now motion we learned, and while learning about the different types of motion, how are they fast or slow, to understand about that, another physical quantity, that is speed, it is introduced to you. The speed is the distance traveled by an object in the given. Now see here, to understand that, first we'll take one example so that it will be easy for you to understand the term speed. If a car covers a distance of 100 kilometers in 2 hours, then the speed of the car, so 2 hours it is taking and it is covering 100 kilometers. How will you calculate? The speed is equal to distance covered by time taken, and you can see that 100 by 2 is 50 kilometers per hour. Yes, if we know the speed of the car, if you know the speed of the car, then even it is very easy for you to calculate the distance also. How? Distance is equal to speed into time. Now see, 100 kilometers. If you know the distance covered by the car and the speed, even we can calculate the time. So time how? Distance by speed, that is 100 by 50, 2 hours. See, in this example, when you calculate and when you try to understand, you can variate the numerical value, 200 kilometers, 5 hours, like that, and you can understand that what is speed, that is the distance traveled by the time taken. And with this, how can we calculate time, speed, all these three components we can easily calculate by substituting the known values, and we can find out the unknown value. Please note down this, children. Next, so points to remember: the speed, the movement of an object in a unit time, is called its speed. The speed is the distance covered divided by time taken. All of you remember, speed is equal to distance covered by the time taken. As we saw in the first example, same distance for in a competition, running race or a riding bicycle race. So same distance, who is covering the same distance in shorter time are considered as the winners. Yes, who are covering it in taking by long time, they'll be taking the position of the next, third, fourth, like that. So that is what the speed is. With the given examples, 3 to 4 examples what we have learned, you can understand that speed is nothing but the distance covered by an object in the given time. So the formula is speed is equal to distance covered by time taken. Now, so when you know the speed, now already we learned about the different types of motion: circular, curvilinear, rectilinear, and all. And another type of motion, two types of very important types of motion this year you will be introduced to you, that is the uniform and non-uniform motion. By now you all know what is speed, then that will be very easy for you to understand this uniform and non-uniform motion. For example, children, here you see here is a car under motion. So the point O, from the O position it is reaching C position. So from the 0, see how many meters it is traveling. From 0 meters to 12 meters it is traveling. And you see the A is another position in between and B is another position in between. And O, A, B, C all are having equal distance. Here you see distance and time both are there. Then only you can find out the speed. So O to A, the distance is 4 kilometers. A to B again 4 meters. B to C again 4 meters. Yes, no, children. So now, how is the car? How it is see every equal intervals, that is from O to A it is taking 2 seconds. From A to B again 2 seconds. Again B to C it is taking 2 seconds. See how is the motion of the car? It is covering the distance in a straight line. It is moving. It is rectilinear motion. It is undergoing, and it is covering equal distance, no children, equal distance and equal intervals of time. The interval you see 2 second, 2 second, 2 second, and distance also you see 4 meters, 4 meters, 4 meters. So equal distance in equal intervals of time, then we call the motion as uniform motion. With this, if you see and draw it in your rough book, and then you will be able to understand what do you mean by equal distance and equal intervals of time. Next, so now when will you say it is non-uniform motion? If the speed of the object moving along a straight line keeps changing, the object is said to be non-uniform motion. The previous example, if the 2 seconds, 2 seconds, 2 seconds, if it is not covering equal distance, That's 4 meter, 4 meter, 4 meter in equal intervals of like time. Like for example, 2 second, 2 second, it is variating because the road is having heavy traffic. Then we call it as non-uniform motion. So what is uniform and non-uniform? Uniform motion, when a body covers equal distance in a straight line in equal intervals of time. I have shown you an example, then you will be able to understand the definition. However, small these intervals, let it be 0.1 second also. If it is able to manage the time intervals equal, then we call it as uniform motion. In this case, the direction of motion remains the same. See, that's why we are specifically we are saying that the object is moving in a straight line. And one example now already I have shown you, you can write on your own also an example. Now variable motion or non-motion. When a body covers unequal distances, unequal means not the 2 meter, 2 meter, once 2 meter, then the 3 meters like that, unequal distances, even though if it is maintaining the equal intervals of time in a straight line, it is said to be non-uniform motion. In this case, direction of motion maybe it will be changing because it may be undergoing zigzag, as if the car is in a heavily traffic vehicle, heavy traffic and all, it might be changing, no children. So that type of motion is called as non-uniform motion. Now, so when we say non-uniform speed and all, you know that time, without time it is not possible to determine whether who is moving faster or slower. You cannot find out the speed of a person, speed of a vehicle, speed of a particle, speed of an object. So time plays a very, very important, measuring time plays a very, very important role in our life. So we measure everything, even the school, even now you have a particular timing for the classes. So time, measuring time. From the olden days, you all know that people used many methods to measure the time. They used the sundials, water clocks were used, sand clocks were used. And later, the watches used today use a periodic motion. One of the most well-known periodic motion is that simple pendulum. So now, so this all after that water clock, sand clock and all, the pendulum, you can see the picture of the clock here. That's why this picture is shown to you. So the pendulum of the clock, that oscillation is periodic. Periodic means it is covering the distance in regular intervals. It is repeating itself in regular intervals. So such a case, so that was only, you all might have learnt about this. Galileo was a scientist. So he observed the pendulum of the clock in a church, and he thought that why it cannot be used for, as it is repeating itself in regular intervals, why cannot be, it can be used for measuring time. So that led to the invention of the pendulum clock. So pendulum, when we talk about pendulum, even these are the clocks earlier used by the people, sand clocks and all. So now one more, see the units of time and speed now. So we'll see before learning about the pendulum, how they will oscillate, just you know the units of the time and speed, children. The basic unit of time is seconds. The larger units only will go for hours, minutes and all. The basic unit of speed is meter per second. The larger unit, just now we saw an example, no children, kilometer per hour. And ancient time, the same picture which we are seeing, sundial, these all were used by the people. Even the shadow only, no, in the sundial, the principle is from the shadow of the sun only they were able to measure the timing approximately. They all did not give the accurate measurement. So for the accurate measurement, later on, as I told, see now we use the different types of watches to measure the time, but all of them work under the principle of periodic motion. So let us have a clear idea about the periodic motion. So the periodic motion, to learn about the periodic motion, that is the, when will you say object is under periodic motion? When it is covering, when it is repeating itself with regular intervals of time. Regular intervals of time when it is repeating, then we say it is under periodic motion. Now, the common example for this is the simple pendulum. The simple pendulum is what, children? It is having a small metallic bob suspended from just a stand. Even you can try your thread and stone, and you can make it to oscillate and you can learn. But as such, in a simple pendulum, there will be a metallic bob and a string. So if the bob is taken to one side and released, it moves to and fro. To means to one side, and again it comes back to the other side also. The to and fro motion of the simple pendulum is called periodic motion, and also it is called as the oscillatory motion. See here it is mentioned, bob is what you can see, thread you can see, O, A, B. So that's what they are saying. If you, like you are playing, O is called an oscillation. When the bob moves from one extreme position A to the other extreme position B, and again it will go to A and it comes back, it is called as the one oscillation. It completes one oscillation. So time period is the time taken by the pendulum to complete one oscillation is called as its time period. You can see the two extreme position means maximum it can oscillate. A again to B, you see here, and again back to A. So from mean position O to A, then again A to B, then back to A. Yes, like that only we will be swimming. Then it is said to have completed one oscillation. The time period taken by the pendulum to complete one oscillation is called its time period. Again, I repeat, the one oscillation means what? From the mean position O to A. Then again it is moving back to B, and again it has to come to A. Then through the it will cross the O and it will reach the A. Then we'll say it has completed one oscillation. So this type of to and fro motion when they observed, that is what we are using in the clocks. So using this pendulum to measure the time period of a simple pendulum. So we can calculate the time period of the simple pendulum. Set up a simple pendulum with a thread and length and thread of length about 1 meter. Move the bob to one side and release the bob. Measure the time taken to complete 20 oscillations. Using a stopwatch or stop clock, we have to stop it. Record the observation. Repeat the activity 3 times and record the observation. Find the time taken for one oscillation. The time period is nearly the same. It will come. Yeah, children. We will continue learning how to measure the time period of a simple pendulum. So as such, you learned that what is time period, you know. By now you know what is time period. The time taken to complete one oscillation is called the time period of a pendulum. Complete oscillation means what you learn. So to complete that one oscillation, what is the time taken by a pendulum? That is the time period of that pendulum. So set up a simple pendulum with a thread of length about 1 meter approximately. Move the bob to one side and release the bob. Measure the time taken to complete 20. You count 20 oscillations. A to B, again it has to come to A, no children. So from O you will start. You will pull it to A, and A to B, again it will come to A. So like that you will be measuring 20 oscillations will complete. It will take some time. So that time you have to record, and then again you have to repeat that. Again second time, third time. For example, if suppose it is taking, so here it is in seconds children. So if suppose it is taking 42 seconds. First time when you are oscillating 42 seconds. So what will be the time period? You have to divide that 42 by 20. So that will be approximately 2.1. So next time when you are doing, due to some error will be there, no? Error will be acting. So next time when you are trying, you are getting 40. So then 40 by 20, 2 is the time period. Next, that is also in seconds only. Time period is also in seconds only. 43 seconds it is taking. So you have to do it by 43 by 2, and you have to find out how many seconds it is. Approximately again 2 point something will come. So that is how we have to find out the time period of the given simple pendulum. Now, one oscillation, the pendulum has said to have completed one oscillation when its bobs moves from one extreme position A to other extreme position B, and again comes back to A. So you can remember as A, B, A. So it will be easy for you to find out. The time taken by the pendulum to complete one oscillation, it's called its time period. So now these all calculating you'll be learning when you go to the about pi and all you'll be learning when you go to the higher classes children. So now if you take a vehicle, in a vehicle, so by now we are learning about the simple pendulum. What for? To measure the time only. So what for the simple pendulum we were knowing about that, because it was undergoing periodic motion, and that principle was applied in the pendulum clocks earlier, and even now in the watches, wrist watches, whatever we are having, this periodic motion only, periodic motion of several substances only is helping us to measure the time. Yes. So when we know that time is very important, measuring time is important. By now you know that speed is distance traveled by the time taken. Now in a vehicle, when we talk about the speed, how are we able to know how far it has traveled or what is the speed of the vehicle? For that, there will be two devices in the vehicle called a speedometer and the odometer. The speedometer is a device which measures the speed of the vehicle in kilometer per hour. You can check in your own vehicle at home, your car or your bike. And odometer is the device which will show the how much distance that is covered. See, all these are related to the distance and the time taken. We are learning about how to calculate the when we learned what is speed. So in the speed, distance covered part, and then we learned about the time taken part also. So far, once if you read the textbook, you will be able to follow what are the different, what is motion, what are the different types of motion, what is the term speed means, and also we learned about uniform, non-uniform motion, and later we also learned about the simple pendulum. So read the up to this part in your textbook and be ready for the next class, children. Bye bye, children.